start with the finders algorithm. So before that, we were talking about various concepts called concept learning, target function, and components of concept learning, and version space, etc. So in today's class, we will discuss the first algorithm, finders algorithm. So before that, we'll have some basic idea about the concept learning. So what is the purpose of this concept learning? Concept learning is to find the best hypothesis. That is the objective of this concept learning. So this concept learning search is to find the best hypothesis that best fits the training example. So we can say concept learning is comes under, so where is concept learning. From the concept learning, we will move on to the version space. Version space, we move on to the learning or a training data set. Training data. So now, so the concept learning is nothing but the overall hypothesis, the set of overall hypothesis. Now, from this, what we will do, we will take some basic samples. We can say, I'm unable to write. Why this pad is not at all writing? Oh my God, yes. I need to keep it like this. Okay, nothing is writing. I'll go with this one. So this concept learning, what we will do, we will identify the best hypothesis, right? So best hypothesis meaning we will collect some base sample hypothesis from the concept. For example, assume concept is like iPhone, right? iPhone is a concept. From iPhone, when I say iPhone, there are different versions of iPhone. 5s, 6s, 7s, 8s, 9s, 10s, 11s, 11 plus, etc. Assume these are the different subsets of iPhone. Now from this iPhone subset concept, I am taking few samples, which is nothing but D. So from the concept, so I am taking few samples, that is nothing but D. So now I need to check whether these samples are belongs to the main subset or not. So that is what the in between subsets are, which is called your version space. Version space is nothing but subset of hypothesis. I am taking, for example, out of this different 10 iPhone versions, I am taking whether 7s, 8s, 11 plus belongs to the concept or not. If so, then such data set, such samples, such hypotheses are version spaces. That is what concept learning concept is all about. From concept learning, we are taking few subsets, then that is a version space. Then we will go on to the training data set. So through this algorithms, first module, we are identifying the best hypothesis, best data set, best hypothesis. That is what we are testing now. So that is what we have taken to this example, whether the celebrity is likely to go for water sports or not. If so, then when it will happen, when such things will happen. So then there will be a different possibility. There are 6 attributes: sky condition, humidity and temperature, wind and water and forecast. There are different parameters, right? So now, so these are the different parameters. So now based on these attributes, we are classifying, we are taking some samples. That is what this table is all about. We are taking some samples. Wait a minute. So the first sample is we used to call instance 1. The instance 1 is nothing but, this is the instance 1. This instance 1 is sunny, warm, normal and strong, and same, warm and same. So now see the sunny, warm. So this is nothing but there are totally 6 attributes: sky, temperature, humid, wind, water, forecast. This is your concept. Enjoy sport is your concept. Whether the celebrity is likely to enjoy sports or not, that is your concept. Okay. So now based on these 4 instances, we are going to predict whether yes or no will happen or not. What is the target concept? That is what the C is all about. Now you note down C is nothing but target concept. So when yes is nothing but positive, yes, he liked to enjoy the sports. Yes, no, when there is a rainy and cold, then no one is likely to enjoy the water sports. So then this is the negative test case. Then the other fourth one is here, yes, positive test case. We will take this training example for enjoy sports problem. We will say we can predict whether the person is likely to enjoy the water sports or not. By seeing this, by solving this problem, we can easily predict. Right. So in order to achieve this, we are introducing two parameters. One is a general hypothesis. Another one is the specific hypothesis. So general hypothesis always represented with the question mark, and the specific, I mean specific, this one is represented with this 5. Okay. Now the concept here is, does days on which SRK, Shah Rukh Khan enjoys his favorite water sports, when he will enjoy. So then you can say instance 1, 2 and 4. This is the SRK is likely to enjoy whenever the climate sunny, warm, normal, strong, sunny, warm, high, strong, sunny, warm, high, strong, cool and change. Then these 3 scenarios he likely to enjoy the water sports. Okay. So that is what this question is all about. Now that I told you earlier, so this general hypothesis represented with question mark. The specific hypothesis represented with a 5. So this question marks generally we used to call positive example. All positive examples are represented with the general hypothesis. More specific examples, specific hypothesis are represented with the 5. Okay. So now this is a complete problem. So we can discuss it later now. Now, the target function is defined as like enjoy sports, x is equal to 0, and 1. I told you x is nothing but predictor variable, 0 and y is nothing but response variable. So now the 0, 1 is nothing but yes or no. If the person is likely to enjoy sports, then you can give 1 yes. If the person is not likely to enjoy, then you can give 0 or no. So when you say yes or 1, then we can say that is a positive hypothesis or positive example. When I say no or 0, that is negative example. I hope it's clear. So now what I am going to do now, I am going to identify the target concept value. So in order to find out the best hypothesis, so this is nothing but a searching problem. So in order to try solve the searching problem, we are introducing 3 algorithms. One is find yes algorithm. The second one is list then eliminate algorithm. The third one is candidate elimination algorithm. For our syllabus, we have a find yes algorithm and candidate elimination algorithm. So the find yes algorithm, today we'll see the find yes algorithm. Tomorrow I'll teach you candidate elimination algorithm. So both are problems. So what do you mean by find yes? What is this yes stands for? Yes stands for most specific hypothesis. So you need to identify the most specific hypothesis from the training samples. That is what this find yes algorithm. So I'll show you. The instances are given. So I showed you, right? So summer, sunny, winter, cold. That is a given instance. So they see here instance x1 and x2. Sunny, warm, high, strong, cool, same. Sunny, warm, high, light, warm, same. So these are my instances. I need to map my instances with the hypothesis. So the top is a specific, nothing but 5. General is nothing but question mark. So now I need to move all the all the positive examples are moved from general to specific, bottom to top. So all the negative examples move from specific to general. Okay. So only you keep in mind, so whenever positive examples are coming, we will edit, we will update the specific. Whenever negative examples are coming, we will go on to general. Meaning, whenever negative examples are coming, you need to make your hypothesis into more general. Whenever positives are coming, then you need to make your hypothesis into more specific. That is what the specific and general. Okay. Now I need to map this instances with this hypothesis. So what I can do, hypothesis 1. So first one is what do you call, sunny, warm, high, strong, cool, and same. Second hypothesis, sunny, warm, high, light, warm, same. Now here you can see the third, fourth one and fifth ones are different. So meaning both are positive test cases, but here the parameter attributes are changed. So whenever such changes are happening, you need to convert it into general one. So you need to change it to specific, I mean question mark one. So that is what we are mapping these instances with the hypothesis. So we will see how to solve this. The condition here is, first we will see the FIND-S algorithm. This concept learning is nothing but learning a task in which we learn our machines by giving some predefined data set. So that is what. So now whenever you are applying any ML algorithms, what you will do, you will take any Jupyter notebook, or you may take any other platform. Finally you will first introduce the library, then finally then you take some few samples. You take some sampled data, then you keep it in CSV file or Excel file, then you try to load it, then you'll apply algorithm, decision tree, random, for whatever it may be. Finally you'll take the result. The same scenario we are proving here in terms of theoretical way and mathematical way, right? So that is what. So whenever you take some sample data set from the empty cars data set or air quality or any other Irish flower data set, you take few samples. So right, so the such samples are used to train your machine, right? That is what the concept learning is all about. The parameters, I think it is a new to you, but the logic is same. Assume I'm creating a concept learning. My concept is eatable. I want to eat some items. So now this is the concept learning. What I will do now, how can I segregate a general hypothesis and specific hypothesis? When I say general hypothesis, if you want to eat, I can bring any eatable items. Either I can bring pizza or samosa or chips or any other corn flour or samosa, pups, something like that. So bringing some eatable item is a general hypothesis. We can say that is a positive case. So then such cases can be represented with question mark. G is equal to question mark. So this question mark is depends on the number of attributes in your data set. I think got it. You have a 6, the previous example, you have 6 attribute: sky, temperature, humidity, and climate, and forecast, and wind, etc. So similarly, if you have 6 attributes, you should represent with 6 question marks. I hope you are clear. So please keep it clear. I am taking you slowly into the problem. Now, when I say positive test cases, then you need to use represent with G with a question mark. Okay, because you no need to touch anything with the general hypothesis. That is what I am keeping this one. Whenever negative test cases are coming, meaning suppose I want to eat a pizza, a specific test case. I don't want to think about any samosa, chips, or something like that. I want to eat a pizza with more toppers like onion, capsicum, tomato, something sweet corn flavor should be there in the pizza on the top. So meaning this is a more specific hypothesis from the general concept learning. Then such things are represented with the phi. So this phi also depends on the number of attributes. Okay. These are the 2 scenarios for this FIND-S algorithm. FIND-S algorithm, we are finding most specific hypothesis for the given problem. What is the most suitable hypothesis for the given problem? This algorithm works only for the positive example. It never works for the negative example. So if negative instances are coming, what we need to do? We need to simply neglect it. Simply you avoid, or simply you pass the loop. That is what this FIND-S algorithm is all about. This is the slide number 18 is very important for solving a problem. So now I'll take you to the
hypothesis will be used in this.
What?
Only general hypothesis will be used in this S algorithm.
No, here only specific hypothesis used. We are not talking about general hypothesis.
No, sir, you told like you will be taking only positive cases.
Right,
So,
I'll show you. This algorithm I kept. See, for each positive training examples, so this is your algorithm. Initialize H to the most specific.
say you are not audible, sir.
Algorithm in terms of most specific. Guys, are you there?
So your voice was
Yes, sir.
breaking,
Now
sir.
it's audible, sir.
Now it's audible.
Yeah, now
Yes, sir.
it's audible. I think it disconnected internet. Yeah. So I think call has come. Okay. So now I am just listen the algorithm, so we will understand. Initialize the H to the most specific hypothesis. Meaning I am assigning initially there are 6 attributes in my problem. So one is sky, another one is the temperature, the third one is the wind, the fourth one is the climate, and then fifth one is the forecast and something other one, right? Strong or something like that. So totally 6 attributes are there. So I am just fixing, initializing the attributes into specific. So initializing the most specific hypothesis A, H. Now, whenever positive training data set is coming, then what I need to do, then I need to take each attributes in the example. Then I need to check whether my attribute value is equal to hypothesis value. Whether my attribute value is equal to hypothesis value. Suppose if both are matching, then I no need to do anything. Simply you reject it. Simply you do nothing. Just pass the loop. Skip the loop. Suppose if both are mismatched, contradictory, instead of sunny, rainy, sunny, warm, or sunny or cold, something, if there are some mismatches coming, then replace that hypothesis by the next more general constraint question mark that is satisfied by the X. Then that H is going to be the output hypothesis. This is your find S algorithm says. I repeat, initialize the H to most specific hypothesis because this is find S algorithm. Find S meaning you are identifying the most specific. S stands for specific. We need to talk about the specific hypothesis meaning phi. Then whenever the case is not satisfied, you replace that most specific hypothesis into more general. That is what we are specifying with question mark. That is the logic behind this. Now I will take you to the problem straight away. So now you take, this is your problem. So example 1 or instance 1, you think there are attributes, there are 6 attributes: sky, air temperature, humidity, wind, water, and forecast. This enjoy sports is nothing but your concept. Now I need to take in I first step 1, I need to initialize my most specific hypothesis H0, initial 0, H0, 555. Why there are 6 5s? Because 6 columns are here, attributes: sky, air temperature, humidity, wind, water, and forecast. So there are 6 columns, so 6 5s I represented. Now I need to take my first iteration 1. In iteration 1, I need to identify my first hypothesis H1. I needs to be identified. My X1 says, instance 1 says, from this problem I am taking this first row. You can see here sunny, warm, normal, strong, warm, same. I am comparing with my initial hypothesis. So initial hypothesis, so just in the first step I am taking my hypothesis as same like instance 1. H1 is nothing but my original instance: sunny, warm, normal, strong, warm, and same. Iteration 1, my instance and hypothesis is going to be the same. Now When the second instance come, what is the second instance? Second instance, first instance is positive. So I am considering this. Second instance also positive. Yes. So I am taking x2 is equal to second instance is sunny, warm, high, strong, warm and same. Now this is my second instance. Whenever my second instance are coming, what algorithm says, you need to compare this attribute value with the hypothesis value. So what I am doing, I am comparing the second value, sunny is equal to sunny or not. Yes, if answer is same, then you just skip it. You no need to replace. You no need to change the hypothesis. So my hypothesis, iteration 2 hypothesis, predicted hypothesis, nothing but same sunny. Warm is equal to warm. Yes, attributes are same. Then you do nothing. Warm. Then normal is not equal to high. Both are not same. When what is the algorithm says, whenever this hypothesis are mismatching, then you replace this original hypothesis with question mark. I am changing this hypothesis into specific into most general. That is what question mark. Then fourth attribute, strong is equal to strong. So you keep the strong as such. Warm is equal to warm. So keep warm as such. Same is equal to same. So keep same as such. So now this is my new hypothesis for iteration 2. For iteration 2, I am comparing the previous hypothesis stage with the current instance. X2 is equal to H1 or not. Suppose if matches, do nothing. If not match, replace with the previous hypothesis with the question mark. That is what I did here. I think it's clear for step 2. Now the third one, step 3, iteration 3. Iteration 3 is nothing but negative test case. Negative, no, which is not belong to the training data set. So what I need to do, so just you ignore it. You keep the previous hypothesis into the same hypothesis here. H3 is nothing but H2. So sunny, warm, question mark, strong, warm and same. Now iteration 4. Iteration 4 is positive. So find us, it will work only for the positive example, not for the negative examples. Okay. So now I am taking x4 is my fourth instance, right? So now this fourth instance is nothing but sunny, warm, high, strong, cool and change. My hypothesis previously you can see strong, warm and same. So warm and same. I'm taking same hypothesis. I'm comparing hypothesis 3 with 3x4. Suppose sunny is equal to sunny. Yes, answer is matched. So you keep hypothesis sunny. Warm is equal to warm. Warm. Strong is equal to, here already question mark with high. So obviously previous hypothesis should be kept as a question mark. Then warm is equal to cool. No, it is not a cool. So it is so again it is a mismatch. So replace the previous hypothesis with the question mark. Then change. Change is not equal to same. So again this is also question mark. Wherever there is a mismatch is happening, that you replace with the general hypothesis question mark. So now this question mark can be anything. So now these three are the conditions, right? Sunny, warm and strong. You can see this one, sunny, warm and what is that fourth one? Strong. So this four are the conditions for this game. Remaining anything, if you change also no issues, definitely people will go for enjoy sports. So the question mark says it is the most general. You can be keep anything, but these three are the conditions. So now this is what we used to call version space. From the most to specific to general, whatever the hypotheses are in between, so such things we called version spacing. Okay. So now sunny, warm, question mark, strong, question mark and question mark. So these things are the final hypothesis. Now the same thing I've tried into the machine learning with the Python. So now I tried with the Jupyter. You can try. I'll give you the sample files. I'll put it in the chat box at the end. You can try. Now I have taken this parameters into my CSV file. I just created one CSV file. Sky, air. First row is nothing but your attributes. Then you keep Then four data sets, training samples, sunny, sunny, rainy, sunny. So 4 samples, line number 2, 3, 4, 5 are my training samples. I saved this training sample in lab1.csv file, right? Now just what I'm doing, just I'm running my just I'm running my Jupyter notebook, just I'm loading my libraries. For running this, I need 2 library, Panda and NumPy. Just I created with PD and NP. This file, this data set is loaded into my same dashboard. I mean, loaded into my same directory. Both my program and the CSV are in the same directory. So now directly I'm loading re.csv of lab1.csv. If not, you need to give the entire file path. Then that is assigned to data. Now I am defining the concept. Just I run the code and I kept a step-by-step output concept. So because the data set are loaded, now I need to define the concept and the target, right, function. So concept is nothing but np dot array of, np is nothing but your numpy, a dot array of data. I am loading from initial to end. So line number 0 to end, but I don't want to use the final column. This final column is nothing but enjoy sports. Yes, yes, no. I don't want to use this column. So I am simply using -1, meaning it will remove this final column. You can check the result by typing concepts of, you see the column. The lab sheet is loaded lab1.csv, but when I run this, I am removing the last column. So it is loaded with sunny, warm, normal, strong, warm, and same. Okay. Now this is the third one. Then I am running, I am defining the target function. Target function is nothing but the last output column, right? So I want only the output column. So colon hyphen -1, the last column only. So np dot array of data. So when you write target, so you will get yes, yes, no, yes, yes. So that is your target function for this given data set. Now I am writing, I'm writing the code. So if the target function, so it will work only for the yes case, right? Only for yes case. Suppose if my target value of I is equal to yes, then what I am doing, I am just checking whether my values are there, the attributes in that array, value of x is not equal to specific h. Then I am replacing with, if not match, then I am replacing with the question mark. Suppose if both, meaning else, meaning what, if both are matched, then I am just passing, I am just pressing, the loop will go to the next one. So that is a simple logic, the same code. Then I am trying to print that specific value, specific hypothesis h, train of concept comma target. So I am training the model. So train of concept comma target. I am loading concept and I am target as a parameter to the training model. So now it will run. So it will check. Train is my function, train of concept comma target. So now this is the case. Now whenever this function is called, then obviously it will print sunny, warm, question mark, strong, question mark, and question mark. The same thing what we got output in that program. I mean problem solving. See here output, sunny, warm, question mark, strong, and question mark and question mark. The same thing we got it here output. Same if you change the data set in this code here, lab1.csv, you can change this orders, you can change this rows. You keep 3 sunny, keep the rainy at the end, or keep the rainy in the second. You try to change the hypothesis and try to see the output. So what happens? So that is what this first find S algorithm is all about. Okay. In the same lab, what we will do, we will try to whatever we are trying with the theory, whatever we are learning with the theory class, we will try to implement the same in the ML lab. Okay, I don't want to go to more some other deviate from the theory concept. Whatever you are trying, first lab is find S algorithm, you can try. Second lab is candidate elimination algorithm, we can try, so that you will learn about the data sets, how a prediction is happening through the algorithms, right? So this is what this find yes algorithm. So we are targeting only on the specific hypothesis. So now sunny should be there compulsory, warm should be there, and strong should be there, right? So that is what. So this one. So finally, by seeing, find this is very, very easy. By seeing the data set, you can guess. See, sunny, sunny here, rainy. So this cannot be possible. This is negative case. So simply you can eliminate it. So all for 1, 2, 3 are sunny, sunny. So you cannot keep sunny as such. Warm, warm, warm. So warm is the answer. So normal, high, high, high. There is a deviation. Then there is a question mark. In all four are strong. Warm, warm, cool. So here also it is. There is the question mark. Same, same change. So here also question mark. So by seeing that you can answer this question.
So here,
Got it?
how enumerate is different than range?
What?
So here the function enumerate, how it is different from function range.
So range meaning here I am taking from considering all the test cases for this case. But here I am checking only for the yes case. Here I am for enumerate, I am passing here concept only in terms of positive test cases. I am not talking about the negative test cases. Here for this, just here we are doing memory referencing, nothing else. We are just converting. Suppose if you give the test cases in uppercase here or with some indentation, it will give you error. Suppose if you use everything with the lower case and the memory, there won't be memory error. Memory reference error won't come. This is just for memory referencing. I'm just copying my thing to the concept, nothing else. Even this is not necessary. So suppose this is, I am passing concept to the enumerate function here. Then suppose if the target function is yes, then this algorithm will work. Suppose if there is no, it won't work here. The same thing can be written in your own way. So this is simple example. That's it.
Excuse me, sir.
Yeah.
Sir, I didn't understand the copy line. Could you explain that?
Copy line meaning, suppose this is, we are just, I did for memory referencing purpose, nothing else. So suppose see here, so I am writing here, this is, even if you write it in capital letter. So here this sunny space, something like that, then you need to do the, either you need to change this upper cases into lower case here. This, where is it is here, lower of concept of I dot copy of, either you need to convert it, then you need to keep it into the local variable, or else you can straight away you can use it. So now you can try this algorithm now. Can you take this problem and say me the answer?
Sir, JP comma question mark comma question mark comma question mark comma ECO.
JP comma
Question mark comma.
So what we will do, we will eliminate all these negative examples here. You remove this negative column. You no need to worry about it. So only positive column. JP is nothing but Japan. So this is just a car manufacturing problem. TO is nothing but Toyota. This is car type. So USA and other things. AU nothing but Audi. Okay. So now JP comma
question mark.
HOT TO. Okay. Question mark. Then
question mark.
Question mark. Question mark and echo. So this is your answer. So first one, we are taking the first parameter JP. So that is your initial hypothesis. Second one is a negative hypothesis, right? So we nothing but H2 is nothing but H1. So H3 is nothing but, we will compare the third one with the second one. So then JP, then instead of HO here we are having TO. So that is your changed. So that is your there is a mismatch, so we will replace with the general specific hypothesis. Then blue 1980 is changed with some other 1990, so that is also question mark, echo and echo. Then fourth one is a negative, again that is same hypothesis. Fifth one is also there is a change here, hypothesis. The sixth one is nothing but finally except JP and echo, all other parameters are mismatched, so then that is nothing but your general. So we are making these parameter into more general specific hypothesis other than the first two. So that is your answer. Here also you can implement, you can use the enumerate. So which will allow you to iterate the complete instances through sequence. But you can use the same indexing for each element. So that can be done with this. So that is what your find as algorithm. So you can try this example. So the main disadvantage is this algorithm is this only considers the positive values. Also, this may not be consistent for the more training samples. So that may not fit for all the hypotheses. So that is what this drawback of this algorithm, because we need to take negative samples also. We need to consider negative data sets also, whether it may be outlier or missing values, etc. We need to consider all the negative data sets and we need to find out with the best hypothesis. But this finders algorithm takes only the positive data set. So this may not be a proper hypothesis for all the problems. So that is what the drawbacks of finders algorithm. The second one is we'll go with the candidate elimination algorithm. This candidate elimination algorithm will work for both positive test cases and negative test cases. Okay. So this will work for the positive test cases and negative test cases. So this is just I kept my written things. I told you whenever there is a two boundary, one is a specific boundary, another is general boundary. Whenever there is a parameters or hypothesis going from specific to general or general to specific, up and down, so then there will be in between hypothesis, maybe the in between training data may be there. That such data sets are just such training examples are we called as version spacing. Okay. So if you want to move from general to specific, then you move forward. If you want to come down, you need to come. You need to travel from specific to boundary. So that is what your version spacing mechanism. So generally these two can be represented with the question mark, a specialized question mark, and this should be represented with the phi symbol. That is what this candidate elimination algorithm. G0 is nothing but general hypothesis in the hypothesis set. S0 is nothing but the specific hypothesis from the hypothesis set. Okay. So this algorithm, Jalon, just I'll teach you, or else just now I have 10 minutes, or else we can go ahead. Just I'll give you the basic idea of candidate elimination. Tomorrow we'll start with the problem. So now this candidate elimination also it will work with the version spacing mechanism. But this algorithm considers both positive example and negative examples, or positive training sample, negative training sample. Okay. So what algorithm says, first we need to initialize the G1 and SO. G1 and SO is nothing but your specific general hypothesis, initial general hypothesis and specific hypothesis. After that, what we need to do, whenever the positive examples are coming, whenever positive examples are defined, we need to generalize the specific hypothesis. We need to touch only the specific hypothesis, S0 set. You need to eliminate the general hypothesis, G0. Okay. Whenever negative examples are coming, you need to make the more general hypothesis, general hypothesis into more specific. So you need to update the G hypothesis. Whenever positives are coming, you need to work on the specific most specific hypothesis. Yes. Whenever negatives are coming, you need to work on the G column. So that is what this candidate elimination algorithm is all about. Now the same example in different order I have taken. So in textbook you may have a sunny, rainy in the third one. Just I have taken second one. Sunny, warm, high, strong, cool, change. But here I have taken rainy, cold. So this is positive instance and negative instance. So how to solve this? So tomorrow this I will teach you how to solve. Even I solved this. I just kept an answer so you can see. Okay. So now you take this as an example and try to identify the finders algorithm for this example for tomorrow's class. You just take a screenshot of it and say me the answer for this problem for tomorrow. So for CAT 1, you will get one question from finders algorithm, one question from candidate elimination algorithm. Okay. Not a program questions, only this type of problems will get. So tomorrow we will discuss the candidate elimination algorithm. Okay. So now I'll send you the code, both the code data set and the code. You can try it out in home. JP and Echo. Someone asked JP. JP is a car, nothing else. I given no, sir. JP is Japan model. H was nothing but Honda. T was nothing but Toyota. A is nothing but Audi. Just don't mind about green color car and all. Just for example, understanding, nothing else. Just I'll post those codes. You can try. Kausik, is the answer for the current last problem given problem or what? Sunny and warm question mark. Sunny, warm question mark. Strong. Strong. Again question mark. Again question mark. Yes, correct. Just I uploaded the lab1.csv and Jupyter file, Python file. You can try it out in Jupyter notebook. You will get it answer. You try to change lab1.csv. You come up with your own data set and try. Okay. Thank you.